Okay, moving from coordinates into vectors. So I is a unit vector in the direction of the positive x-axis. So unit vector coming this way. J, y-axis, and z along the z-axis. And if you remember, a unit vector has length or magnitude of 1. We'll come back to those in a short while. I quite like using column vectors. So I is 1, 0, 0, J, 0, 1, 0, and K, 0, 0, 1. So that's the definition of those. And try and remember to underline your vectors. It is quite important. I know it's a little bit annoying, but it is quite important. Right, I've got 2 examples to go through. So consider the points. A 2, 0, 5, B minus 1, 1, minus 3. I wouldn't bother trying to draw them and think about where they are in 3D space. Position vectors of A and B. So the position vector of A is the vector that takes you from the origin to A, and the origin is fixed. So you can think of vectors as being free floating things that you can move around. But if they're coming off of the origin, then they're very much tied to the origin. This notation is quite nice because you can see you're going from the origin to A. The other notation for the position vector of A, so we tend to use capital letters for points. So lowercase a as a vector. So that's also used as the position vector of A. So both of those notations are good to have under your belt. And then we're literally just going 2, 0, 5. So you just write the coordinates as a vector instead. Position vector of B, so that goes from the origin to B. Again, you can use lowercase b for the position vector of B. Minus 1, 1, minus 3. I could write this in IJK notation. So in IJK notation, that's minus 1i, so minus I plus j minus 3k. I much prefer column vectors. I just think they're easier to work with. And it's fine just to convert into column vectors in questions if you want to. I think Jamie tends to do that, but if not, you could think about moving into column vectors a little bit more if you didn't do last year, or not, up to you. So this one, 2i plus 5k, like so. To find the vector AB, so this is really straight revision from last year. AB is the position vector of B minus the position vector of A. So it's the second minus the first. Again, you may see that written like that. And so you do the position vector of B minus 1, 1, minus 3, minus the position vector of A. So that's just a straightforward extension from what you were doing last year. Minus 1 minus 2 is minus 3. 1 minus 0 is 1. And then minus 3 minus 5. Minus 8. So AB, position vector of B minus position vector of A. To find the length of AB, so the length of AB is the magnitude of AB, and just reminding you of this notation. So magnitude of AB is written like that, and that's just Pythagoras extended to 3D. So like you did with the coordinates, so you do the square root of minus 3 squared plus 1 squared plus minus 8 squared. And that gives you the square root of 74. And then a unit vector in the direction of A. So A is equal to 2, 0, 5. And to find a unit vector, you need to divide A through by its magnitude. So the magnitude of A is, using Pythagoras, the square root of 2 squared plus 0 squared plus 5 squared, which is root 29. So a unit vector in the direction of A, so that's written like that, it has this sort of funny hat on, and it does get called hat, sadly, is 1 over root 29. So I'm dividing through by the magnitude lots of that vector A. So you can leave it like that, or you can multiply right through by 1 over root 29. I'm going to run out of room. So that's 5 over root 29 underneath. There we go, just do that. And if you find the magnitude of that now, so if you do the square root of 2 over root 29 squared plus 5 over root 29 squared, you will get 1. But it's in the direction of A, because this is a scalar multiple of A. Right, I have one other example to do. I think I've just got time rather than doing another video. I really ought to have got a webcam, but this is kind of working, so I'm sticking with it. Right, so A, 2 minus 3, 5. If I want to do 4A plus B, then you're literally just doing this. So just checking you're okay with this, which you should be. So you do 4 lots of 2 minus 3, 5, which is 8 minus 12, 20 plus 4 minus 2, 0. So I'm just assuming you're kind of okay with this, really, because you did it last year. So 8 plus 4 is 12. Minus 12 minus 2 is minus 14. 20 plus 0 is 20. And then you could write that as 12i minus 14j plus 20k. 2a minus 3b, so we've got 2 lots of 2 minus 3, 5. Minus 3 lots of 4 minus 2, 0. I'll leave you with that one. That gives you minus 8. 0, 10 when you work through it, but you can just literally do 2 times 2 minus 3 times 4, which is minus 8, so you can just literally work through that following BIDMAS. And which of the above is parallel to 4, 0, minus 5? So parallel vectors are scalar multiples of each other, which is why that unit vector works as well. So you should also know this. So that's kind of one for your notes. And so because this one here, so minus 2 lots of 4, 0, minus 5 equals minus 8, 0, 10. So 2a minus 3b is parallel to 4, 0, minus 5. So you just need to show that it's a scalar multiple. One of them is a scalar multiple of the other, and that's enough to show that they're parallel. So it's enough working there, but you definitely do need to demonstrate this bit here, and then a little explanation to get your marks. I've set you some questions on this. If you want to do a few more of them, please do. I've kind of set you kind of enough that you've done a bit on each, but if you want a bit more practice, there are more questions in that exercise which you can look at and ask if there's anything there that feels a bit blurry.